okay? In general, if we're talking about a random variable, we give it a letter, okay? So just like in algebra, if we want to talk about something which we don't currently know the value of, or the value can change, like a random variable, right? We give it a letter, and we choose the capital letter to represent that random variable. So for example, in this case, x represents the number of number of siblings which somebody has. Okay, so the capital letter X is going to represent the number of siblings which somebody has. Okay, but if you were talking about heights, this would be the heights of people. If you were talking about the number of Red Bulls in a bag, this would be the X. Does that make sense? Okay. Now, if you want to talk about a particular outcome, you use a lowercase letter. So the capital letter represents the random variable, and the lowercase letter represents the value. Okay? So as an example, if I wanted to go back to question 1, okay? If I want to go back to question 1, which is what's the probability that somebody has 2 siblings, what I'm literally going to write that as is what is the probability, capital X, because X represents the number of siblings, is equal to 2. So literally the way which I'm going to read that is what is the probability that my random variable, which remember is the number of siblings, so what's the probability that the number of siblings is equal to 2? Does that make sense? Okay. What would question 2 be? How could I write question 2 using this notation? Go on. Go on, Alice. Good. Literally like that. Okay. Are you happy this is now not ambiguous, right? This is no longer ambiguous because it's clearly not including that 3. Oh, fewer. Sorry. So it's just literally the other way. Yeah? Good. Excellent. Okay, so what about question 3 then? How could I rewrite that?
Capital X more than 6.
Good. What about question 4 then? So now we can make the decision, are we going to include 3 and 6? Or are we just going to include 1? Are we not going to include any of them? So how could we do that?
3 more than capital X.
Mm-hmm.
6.
Good. Now, if this case, have I included either the 3 or the 6? No, I haven't, because it's strictly speaking less than, right? If I want to include the 3, how could I adjust this? Good, less than or equal to 3. If I also wanted to include the 6, how could I adjust this? Again, same kind of idea. So does that make sense? If you use the notation, it suddenly becomes a lot clearer, okay? I suppose we should come back to this as well. So can I just borrow your attention to... Yes, Mohammed. Yes, absolutely. So you notice that I always write my lowercase x's like curly things, okay? This in here is a capital letter because I'm literally talking about the number of siblings, okay? Now come back to this, come back to our probability distribution. How could I adjust these 2 things so it's in line with this notation? So for example, siblings, would that be capital or lower? Good. So this would literally be read as x equals lowercase x, okay? Because all of these numbers here, 0, 1, 2, 3, 4, 5, 6, etc., would all be my lowercase x. Is that clear? Does that make sense? Yeah? And then here, this is no longer frequency, this is now probability. So how could I adjust this? Does that make sense? Right? So it's a bit of weird notation if you meet it for the first time, but literally all it means, x is the number of siblings, and the lowercase letter x is the value, the outcome. Does that make sense? Good, fantastic. So there you go, so I've converted all those there. So therefore, just a bit more practice. Here I've put 4 more questions, but this time using that notation. Can you have a go at finding those probabilities for me? Okay, so in the first hour, we were talking through the idea of probability distribution. Okay. Now, you notice that one of the limitations of a probability distribution now is you've removed some information about the data. Okay. So, for example, if I just gave you this, you don't know how many people were in each category anymore, do you? okay? Because it's just a probability. All you know is the chance of walking into this room and selecting somebody who have no siblings is a 53% chance. But you have no idea how many people in here actually have no siblings anymore, okay? So unless you know something about the data which it was collected from, a probability distribution just simply says it tells you the probability of selecting somebody with that. Does that make sense?
Without the number of the sample?
Exactly. So you don't know about the number of the sample. Yeah? So in other words, a probability distribution removes information about the data in which it was collected from. But that's kind of the point of a probability distribution, because it's just a way of connecting together the probabilities of the outcomes. Does that make sense? Yeah? Good. Okay.